Welcome back to the last section we're going to consider for our review of factoring in Chapter 6. And we are right now at Section 6.6, where the factoring really starts to get messy because you may have to use multiple types of factoring, which is really the best thing to know when you're looking at the work in Chapter 7, because you have to be able to distinguish between what type of factoring to use. So this is a really important section. So feel free to stop the video at any moment to copy this information down. And what we have here is a checklist of what types of factoring you may need to utilize when you're looking at any polynomial that is up for factoring. I'm going to go ahead and separate the first one now. This needs to be made really clear. I've said it before, but perhaps looking at this chart may do a nicer job to kind of illustrate the importance of this. Whether you're looking at a binomial, a trinomial, a polynomial of 4 terms, the first type of factoring that you always must look for is a greatest common factor. Whether that greatest common factor will be a number, whether that greatest common factor will be a variable, or a combination of a number and a variable. You always must look to factor a greatest common factor first. If you fail to do this, it will make your factoring difficult, if often not impossible, and it may also stop you from recognizing a simpler type of factoring that you may be able to use to make the factoring a lot easier. So the first type of factoring that you always must look to do first will be the greatest common factor. If you have looked at the polynomial and you determine that there is no greatest common factor, or once you factor the greatest common factor of a polynomial out, there are several other types of factoring that you may need to consider further. So to determine what types of factoring could be used, we use the following. If you have a binomial that you're either looking to factor or factor further, there are 3 types of factoring that are used to factor binomials: the difference of perfect squares, the sum of perfect cubes, and the difference of perfect cubes. The difference of perfect squares, for the purpose of review, is covered in section 6.4, and you can see that on the video. It's not covered heavily because the method of factoring is not incredibly difficult, but if you have difficulty with this type of factoring, we will have a review session on it held in class. But please try the examples online, and please view the videos in this section before spending too much time on class on it, because you want to make sure you have enough time in class to get all your rational expression problems solved. The next 2 types of factoring that you could have for a binomial are the sum or the difference of perfect cubes. This type of factoring is covered in section 6.5, and there will be review problems that will be shown for this. Again, not too many. It's mainly a formula process. There are examples you can view in the book. There are examples you can also practice online with MyMathLab. Again, we will look at this in class to refine this technique for those students that need that refinement. So, these are the 3 types of factoring that can be applied if you have a binomial to factor. If you have a trinomial to factor, most typically, if the trinomial is factorable, it will be factored into 2 binomials. But also note that it's easy to factor the 2 binomials if the a coefficient, as I've mentioned earlier in videos, is equal to 1. When the a coefficient is not equal to 1, we have to apply the techniques of factoring by grouping within the normal process of factoring trinomials to have those factored. So factoring trinomials is covered in sections 6.2 and 6.3. Please look at the videos if you have any questions on those techniques. For polynomials of 4 terms, we apply the type of factoring known as factoring by grouping typically. Now, we can't always factor them, but if it can be factored, we apply this technique. In 6.1, we factor polynomials that contain 4 terms using this technique only. In 6.3, we use the technique of factoring by grouping as a step in the process in factoring trinomials. Now, I've said a lot to this here. Again, please remember that you can stop the video at any time to take as much or as little as what I'm saying down. I'm going to refer to this chart and keep this information to the right-hand side of the screen, so as I work through a problem, you will have the opportunity to look at the steps involved in simplifying polynomials that may contain several steps in the factoring process. Please look to the next video for this inclusion and for simplifying more complex polynomials that require a lot of steps in factoring.